So in this video, we're going to talk about how to solve stoichiometry problems. So this one is not about the mole ratio, it's the real stoichiometry.
And so we're not going to have that.
So if you watch our previous videos, we were able to make a roadmap. We're able to make a simple technique on how to convert moles to other units. Okay, so this is the roadmap that I'm talking about. So we have the mole to the number of particles and vice versa. Then we were also able to make an enhanced version of this roadmap where you can go from any unit to anywhere. For example, you're given the mass, then you want to get the number of particles. So you just have to follow a certain pathway. So the plan will be mass to mole to number of particles. So here we're going to use it again, but in another form. I have this thing called the Modified Enhanced Roadmap, or the MERM. So what does the MERM look like? So this is the MERM that I'm talking about. Okay, it's the same as the enhanced roadmap, but what changed is you have two enhanced roadmap combined, okay? And you also have the mole ratio, which we talked about in the previous video, right? Okay, so in this kind of problem, you have the known substance and the unknown substance. If you're given the grams and you want to get, let's say, the number of particles of the unknown substance, you just have to follow the pathway grams A to moles A times the mole ratio, which will give you the moles B and the particles B. To make it clearer, let's have an example. Let's consider the reaction between iron and oxygen, which will yield ferric oxide, or iron 3 oxide. So the question is, how many moles of Fe2O3 are produced when 0.275 moles of iron, Fe, is reacted? So we're going to use here the method that I showed you in the previous video.
I would like to see it.
The first step here is to write the T table. Okay, if you remember this, that's good. If not, please check that video. So you put the given to the upper left. So 0.275 mole Fe. Then in the bottom right, put the unit of the given so that they will cancel each other. This time, you have to copy the coefficient from the balanced chemical equation. So we have 4. Then put the unit of what you want to get, which is mole of Fe2O3, and copy the coefficient. Same as the mole ratio, okay? Because this is the mole ratio.
Okay, this here.
Cancel the unit. We now have mole of Fe2O3. Then do the math, that will give you 0.1375. But the given only has 3 significant figures, so our final answer will be 0.138 mole of iron 3 oxide. Okay? Next, how many moles of Fe2O3 are produced when 31.0 moles of oxygen is reacted? Same method. Draw the table. Put the given to the upper left, then write the mole ratio using the balanced chemical equation. Cancel the units. We will now get the mole of Fe2O3. That will give us 20.66666667 mole of iron 3 oxide. Considering the number of significant figures, the final answer will be 20.7 moles iron 3 oxide.
Very good.
Okay, so do this on your own. How many moles of oxygen are needed to react with 8.9 moles of iron? Okay, so pause this video and do it. I will not show you the solution because that's your task, okay? But the final answer should be 6.7 moles of oxygen. So comment your solution below, okay? Considering the same reaction, How many grams of Fe2O3 are produced when 42.7 grams of iron is reacted? It looks so complex, but don't worry. It's very simple. In this question, we have to use our modified enhanced roadmap. Okay? So, we are given 42.7 grams of iron. This is your known substance. Okay? We're looking for the grams of Fe2O3. So by just looking at the merm, you will already know what to do. Okay? Plan will be to convert the mass of known substance to its mole. Then get the mole ratio to get the moles of substance B and convert it to its mass. Easy, right? Now let's try to solve it. Draw the table. Of course it will be enhanced too, right? So it now looks like the sword of Renji in Bleach. Or a fishbone. Call it whatever you like. Okay, so we start with the given. Boom, 42.7 grams of iron in the upper left, leftmost. Then copy the molar mass. Then use the molar mass. You know how to get this, right? If you forget how to get this, just check the other video that I made. Then we have to cancel the unit. We are now in mole of iron. Okay, we're here. Now we need to get the mole ratio. And again, to get the mole ratio, you have to use the balance equation. So in the bottom, we will put the mole of Fe because that's the given. That's down the current given. Copy the coefficient 4. Since we're looking for Fe2O3, we'll put its unit in the top. Then we copy the coefficient. Okay, cancel the units. We are now here, the mole of Fe2O3 or substance B. Then to get the grams or the mass, we have to use the molar mass. But this time, the grams is in the top, the moles is in the bottom, okay? Then you have to cancel the units. We will now have this as final answer, 61.0 grams Fe2O3. It follows the significant figure. Now let's have this combustion reaction.
Imagine how tired we are of it.
So again, a combustion reaction is when a hydrocarbon reacts with an oxygen to form carbon dioxide and water. So if you can't remember that, just check the types of chemical reaction video in the playlist. Just by observation, you can see that it is not balanced. Okay, I will not teach you how to balance this because we have another video for that. But the balanced chemical equation is 2, 13, 8, and 10. Okay, just review how we get that. Just review how we got that. Okay, so the question is, how many grams of CO2 or carbon dioxide are produced from the combustion of 100 grams of butane? So first, identify the known substance, which is 100 grams of butane. Then the unknown will be the grams of carbon dioxide. Same step, same procedure, same concept, same principle. Do the table, the modified table. Write the given to the upper left, then make use of the molar mass to get the moles of butane. Now that you have the moles of butane, remember that we're looking for the moles of carbon dioxide for now. Okay, so we have to make use of the mole ratio, and we get that from the balanced chemical equation. In the bottom, you will have 2 moles of butane, and in the top, you have 8 moles of carbon dioxide. Then, to get the grams or the mass of carbon dioxide, we have to make use of the molar mass. But this time, the grams is in the top and the moles in the bottom so that the moles will cancel. Canceling all the units, will have the grams of carbon dioxide. The final answer will be 303.0 grams carbon dioxide. Okay, next, how many grams of water are produced when 5.38 grams of oxygen is reacted? Same procedure, draw the table, boom. Then Write the given, 538 grams. Use the molar mass, cancel. Use the mole ratio, 13 in the bottom, 10 in the top. Where did I get this? From the balanced chemical equation. And make use of the molar mass. Then cancel all the same units. We will have 2.33 grams of H2O. If you didn't get this, well, you have to rewatch the video.
I understand your concern, but I do not have the same concern.
Okay.
Okay, so that's it. That's it for stoichiometry. Very simple. Just copy the steps first. Okay, draw the table, write the given, blah blah blah. And you will really just make it and pass chemistry. Hopefully. Okay, so I have more videos. So the yields of chemical reactions and the mole ratio problems. So if you want, please check them out and don't forget to subscribe, like, comment, share it to your friends, turn on the notifications, share it again, and yeah, watch it a lot of times.